Burke. Welcome to our discussion on overcoming extreme weather. We at Northrop Grumman are happy to present this event in conjunction with our hosts, the American Astronautical Society and the American Meteorological Society. We support weather and environmental solutions across the federal government and are honored to present this exciting conversation. We'd like to thank all of our experts for participating today, and with that, I turn it over to our moderator, Laura Delgado Lopez from the Secure World Foundation. Laura, over to you.
Thank you, Ron. First, let me introduce our panelists. Joining us today are Dr. Louis Uccellini, Director of the National Weather Service of the National Oceanic and Atmospheric Administration, NOAA; Jason Samenow, Weather Editor at the Capital Weather Gang; Maria La Rosa, Meteorologist at the Weather Channel; Amanda Mitchell, Master Student of Integrated Science Applications at Millersville University; and Dr. Moshe Shepard, Past President of AMS and Georgia Athletic Association Professor at the University of Georgia. We will kick off the conversation and then be ready to take your questions. So please join the conversation using hashtag ExtremeWX and hashtag NGWeather. And with that, let's get started. So the first question for you, Maria and Jason, you and fellow meteorologists are at the forefront of communicating with the public about extreme weather. What do you think they should need to know about extreme weather and the challenges and the opportunities for dealing with its impacts?
Well, thank you so much for this opportunity to talk about obviously a very important subject. And being in the weather business, but also the communication business, I think one of the big challenges continues to be the communication of the problems with severe weather. And it's not just 10 severe weather events, it's each and every single one that happens every day, from flash flooding to hurricane preparedness to severe weather warnings. We find it over and over again when we go into the aftermath of a situation. People are still saying, it took me by surprise, I didn't see it coming, I didn't know that I needed to be aware of this. I think that's one of our big challenges going forward, is to continue to emphasize and prepare the public for extreme weather. And certainly when you are factoring in the future of extreme weather and being that we're going to be talking about extreme events more often, I think that'll continue to be something that will challenge us as broadcasters and meteorologists.
Jason, do you want to jump in?
Yeah, absolutely. And thanks so much for having me on. This is a terrific opportunity to talk about weather extremes and preparedness. And I think the points Maria just made were really important. And I just add that one of the most important things that a consumer of weather information needs to know these days is that you have to know who your trusted sources are. These days, there's weather information everywhere. You'll see it on Facebook, on Twitter, in the newspaper, online. And so it's really important that every person who's depending on weather information knows where to go when the weather is serious, when the weather is life-threatening, and to also be able to filter out some of the bad information which is out there, which you see sometimes getting shown on Facebook, some of this misinformation. So it comes back to who is providing weather information reliably every single day, who is engaging you, who can you come back to each and every day for trustworthy information. That's really important. The other thing I should emphasize is that you should have a plan for what you're going to do when there's severe weather and when there's extreme weather. Have a plan with your family, with your friends, know where you're going to shelter, have an emergency kit ready, and just be prepared for those dangerous situations, because having confidence and knowing what you're going to do will make you a lot better prepared and a lot more ready for these severe weather situations.
Indeed, and that actually sets up perfectly for the next question to Louis. Of course, it all begins with the National Weather Service. So can you talk about how investments in observational platforms, including satellites and high-performance computer models, really help build a weather-ready nation?
Well, Laura, thanks, and thanks for having me here. To answer that question, let me build on the previous discussion. With the increased severe weather, another aspect of this is the increasing vulnerability of people to the extreme weather events. And This is due in part to the increasing population, people living in vulnerable areas, increased infrastructure that has to be protected. So this poses challenges to us as a meteorological community, many challenges, and we're trying to put our arms around this through an initiative, a strategic initiative to build a weather-ready nation, which is being promoted through the Weather Service, but actually one of our major messages is that it has to involve the entire enterprise. This is not just, this can't succeed if it's just a Weather Service activity. So let me give you an example of how this all plays out and how it ties back into the observation area. We now have more people living along the coastline. We have more infrastructure along the coastline. So when a hurricane approaches a coastline, decisions to evacuate, decisions to take mitigating steps actually have to be made further in advance. We can't do everything at 24 hours in advance or 48 hours in advance. Evacuations start at day 4 and day 3 before this event. So this puts extra pressure on our forecast to extend a more accurate forecast further out in time, to be able to convey the level of uncertainty and certainty, to provide impact-based decision support services 4 days ahead of time. This means our forecast at days 7, 6, 5, 4, 3 has to be increasingly accurate, has to be consistent. We have to be sending a consistent message for FEMA, for regional and local emergency managers to make that decision. Well, how do you make those kind of forecasts? So you have to have improved models. Everybody now knows, I think numerical modeling is all part of the common language amongst people. I get asked on the street about our comparison with the European Center, for example. It's amazing how pervasive this whole discussion on modeling has become. Well, to make that successful, it's not just the models, it's the big computers, and it's a global observing system. Especially for the medium range to short range forecasts, you have to have a global observing system. Even if you're just interested in making a local forecast, it all traces back to the global observing system. And today, we ingest about 2 billion observations a day. That feeds into our model cycle over that 24-hour period. These observations are dominated now by remotely sensed instruments, both on the ground, like radars, but especially the satellite system, which provides the global observations which help make this happen. So you have the polar orbiting satellites, you have the geostationary satellites. All of this information is brought into the models, and we're able to show now, and to initialize those models, and then to run these extended range forecasts. And we're able to show, as an example, that the microwave data collected from polar orbiting satellites and the infrared data is in the top 1, 2, or 3, depending on how people actually evaluate the data, out of all of the data that we receive and use. So, you know, the observations is a key part. And the last point I'll make here is that there is no silver bullet in the observing world. There are strengths and weaknesses in every observing system. So what we do when we take this data and bring it into the models through a step we call data assimilation is that we're always working to extract the useful information from those observations while avoiding the weaknesses. So this is a key part in making these observations work within the numerical modeling system.
Great. And so, of course, the next generation satellite and other technologies are about reducing those vulnerabilities and those weaknesses and trying to get even more precise and accurate. Marshall, I wonder if you can talk about what some of those new technologies coming up are about and how will they improve prediction and preparedness?
Well, thank you for having me. First of all, I'm coming to you from the beautiful headquarters of the American Meteorological Society, but I want to say hello to my students and everyone back at the University of Georgia and my colleagues at the Weather Channel. Look, we've made significant strides in technology. If we look at Superstorm Sandy, the tornadic events, Reno and Moore, Oklahoma, even the Atlanta snow jam, the weather forecasts were actually pretty good. I think where there are challenges still are in terms of the communications how people are perceiving this information and the decisions that they make. There are people that will say, oh, if it's a Category 3 storm, I don't need to worry about it. In fact, we know that Category 1, Category 2 storms can be of significant danger. There are people that I believe still don't understand what an advisory versus a watch versus a warning are. So there are significant challenges in terms of social sciences, communication, and perception that need to be advanced, and I think that's one of the things we'll see moving forward in the Weather Ready Nation. We'll be dealing with that on the show Weather Geeks on the Weather Channel Sunday at noon. But getting back to technology, NASA and NOAA are launching a next generation suite of satellites that include the JPSS, the GOES-R satellite. Many people aren't aware of the fact that NASA is launching spacecraft like the Global Precipitation Measurement, or GPM mission. I served as the deputy project scientist on that for years when I was at NASA. This information is being assimilated into the model, and I want to touch on a point that Louis made. I mean, I could be like at McDonald's and someone finds out I'm a meteorologist and they start asking me about Euro versus GFS. Oh, which one do you think's better, Dr. Shepard? And as Louis mentioned, over in many cases, I think Euro does lead us in some stats, but let's not forget that much of the data being assimilated into the European model is weather satellite information coming from NOAA, NASA, and our partners around the world. Lest we not also forget the emergence of the dual polarization weather radar network that the National Weather Service and NOAA has installed. These technologies not only are technological toys that we as scientists think are neat, they're saving lives. It's important for us to understand that the weather information, the National Weather Service, and all the good people working there are, to me, as critical to the United States and the world as homeland security and national security infrastructure, and we need to value them in that way.
Excellent. I would rephrase to say that I'm glad you highlighted the international cooperation aspect of this. And of course, leading in as a weather nation is part of the nation's leadership in the world. And now let's talk about that challenge that you, Marshall, and Jason, and Maria all alluded to, this challenge of communicating with the public. Jason, I wonder if you might lead us off. What challenges do you experience in communicating extreme weather risks, and how can technology help amp up communications?
Sure. So whenever we're talking about an extreme weather event, we're dealing with uncertainty, and so there might be a range of scenarios. And there's a tendency by some communicators of weather information to focus on just one particular scenario rather than communicating the entire range of possibilities. And so I think as communicators, we really need to show some responsibilities and not just focus on the doom and gloom, or maybe not necessarily just try to downplay a particular weather event, but give people the full range of possibilities so they'll be better prepared in how to respond. Information is power. When there's a severe weather event or a potential severe weather event facing people want to know all of the possibilities which are on the table so they can make best decisions how to prepare based on their own risk tolerances. Some people may be more or less risk averse than others. So I think as communicators, we really need to focus on providing people as much information as possible, but at the same time also responsibly communicate what's most likely and what's least likely to give people a sense of that risk. Now, in terms of technology, how that helps inform the type of communication we're doing, of course, satellites and radar technology are all real-time tools that we can use to engage the public in the weather information we're providing. They provide incredibly compelling visual information which can get people really interested and engaged in weather. And they're really our eyes in the sky, and they provide, in the case of radar and in satellite imagery, they show where the storms are, which in visual confirmation is so important in terms of helping people take action. So these visuals, which our remote sensing technologies are providing, are frankly invaluable, and we need to make sure investments in those technologies are sustained.
Indeed. And on this note of using technology to better reach the public, let's talk a little bit about social media. Maria and Amanda, can you both talk about how social media is playing a role, and perhaps examples of some compelling ways people can engage with this next wave of science and technology, just as Jason alluded?
Amanda, would you like to go first?
Yeah, that's fine. I think social media has made a crazy amount of impact on our today's society. Things like Facebook, Instagram, Twitter. I mean, Twitter right now, you can have live feed. You can get kind of feedback of what's going on in your area. You can see what kind of disaster is happening or what has happened because of an extreme weather event. You have things like Instagram where people can post pictures of what kind of damage was done. So then you have people like Red Cross who can manage to see what area needs attention first. You can also use Facebook where you can talk to your family or friends and tell them, hey, this is about to hit your way, or hey, I'm okay, I'm fine. But yes, social media has definitely had a huge impact on our society, and definitely within the last decade. And I think it's going to be what helps us get the word out for people who don't download apps for weather events. Maria?
Yeah, I would absolutely agree. It's so important that it's become a big part of our broadcast every hour of every day on the Weather Channel. We take in Twitter pictures. We look up people who have posted something on Facebook to do an interview if they've just experienced something. Something that just comes to mind, of course, is all the flooding in the Southwest. We've had some incredible stories come out of there. But I love what Jason said too, is that it's almost, everybody is basically an armchair meteorologist, and there are a lot of people out there with a lot of information and a lot of knowledge about weather but may not be meteorologists, but they're out there, they're putting information out on social media. So when you choose your outlet, you do have to choose carefully. We would like to think that, of course, Weather Channel is the place to go for the weather information that you need to prepare your family, but there is a lot of noise out there, and I know myself as a meteorologist on Twitter, on Facebook, on Instagram, on Google+, that I don't want to add to that noise. I don't want to perpetuate something through a retweet that I didn't do enough background check on. For instance, I retweeted a picture from during Superstorm Sandy, and it took off. It was Atlantic City, and I immediately panicked because I did not do my homework and double check to make sure it was a legitimate picture, because I can't tell you how many times I've seen circulated these crazy weather pictures attached to certain events, and that is bad communication. And so I think a big part of the broadcast world is taking responsibility and making sure that our sources are good, so that that information that comes out from us is trusted every single time. And I think that's a big part of it, because everybody knows nowadays you can pick and choose your outlets. You can choose to listen to me or not, follow or unfollow. So you are competing with a lot of outlets out there putting information out. And I think that is going to be another big problem when it comes to communication and preparing the public, because the public can pick and choose which information they want to listen to or not want to listen to. Like Marshall said, some people hear Cat 3 and think, I'll be fine, but that's not necessarily what we want to communicate. And I always go back to, whenever I put anything out there, verbally on air or on social media, would I be telling this to my brother, my sister, my mom, my dad? That's always my check, because I want to make sure that people that listen to me know that that's exactly what I'm going to be telling my friends and family, the people I love the most. And I think that helps keep the hype, if you will, in control, because I don't ever want to be part of the hype. And as Jason mentioned, we want to make sure that we communicate all scenarios, but at the end of the day, people want a yes or no. Do I evacuate my family or don't I? I don't know if I necessarily need to know all of the scenarios, but basically that's what it comes down to. And I think as broadcasters on social media with that power, we have to take it very seriously, and sometimes that means scaling it back, and sometimes that means grabbing people by the shoulder and saying, no, you need to do this now.
Yes, so it's also a matter of authority. And so on that note, Louis, can you talk about what your interaction or your relationship in terms of NOAA and the Weather Service is with meteorologists and forecasters like Jason and Maria, the people that take that message on and send it out to the masses?
Well, one of the major aspects of accomplishing a weather-ready nation, of course, is establishing partnerships or securing or building on existing partnerships. And clearly, one of our key partners is the media. and ensuring that we get the information to them in a timely, reliable way, that they can do their job. They can do what they have to do to communicate on out. So, that's an important part of what we have to do every day. Of course, we also rely on what we're finding, what we see coming in from social media to sustain our situational awareness, especially during these critical weather events. And the other aspect of using this information, it's not only with our partnership with the media, we have a developing partnership with the emergency management community at every level, and ensuring that we get the information they need for their critical decisions as we are approaching an event. And this puts extra pressure on us because we have to ensure that we're providing that consistent message within our own organization that maps into all the other information that's out there that Jason's alluded to. So we work these partnerships not just during an event, not just the 5 days before the event, but we practice during the off times to ensure that we all get the response that we want. So yes, I mean the whole communication issue, we're part of that, but we have to rely on our partners with respect to getting out to the general public our information.
Jason, I wonder if you can add on to this theme about communication and continuous engagement with the public. One of the things I find really interesting about, for example, the website and the work that the Capital Weather Gang does is sometimes you will have other meteorologists, amateurs or professionals, contesting some of the information that you guys put out. So how does that add to the dynamic? And do you think that's a testament to greater awareness of weather and weather risks?
Yeah, well, I mean, I think the fact that we have so many different voices and players involved in social media is a real strength. I mean, what social media has effectively done is it has formed a bridge between the providers of weather information and the users of weather information. So it's not just, it's no longer someone just tuning into the news and hearing a weather forecast. Now someone can interact with the meteorologist providing that information, ask questions, and we can also interface with meteorologists, amateur weather enthusiasts, and this can become a discussion which continues around the clock 24/7. And so, yes, sure, there are some clear downsides of social media because there's some of the noise that Maria alluded to, but overall, it has a ton of strengths in that it makes weather a conversation which just continues, in which so many different voices can convey expertise, in which we can all learn from one another. And so I think at the end of the day, social media, despite some of the criticism it comes under, has been an incredible revolution for weather information, and getting back to some of the real-time value that Amanda referred to in terms of providing damage pictures, visual confirmation, and just being this constant stream which is always on and keeps everyone informed and hopefully safe as well.
Indeed. Amanda, let's turn back to you, and as you look forward to an exciting professional career and you'll be grappling with some of the challenges that we've just been talking about, what insight do you have from the perspective of a young professional, and what questions do you have for the other folks in the panel?
We definitely look forward to the advancement of prediction, obviously communication with social media and preparation. Definitely things that are going to affect us, like supercomputers who are going to be collecting a lot of data. It's going to increase our prediction and the everything about it. Also private sectors, people in companies who are working on things like commercial vehicles and phones that can now pick up pressure, temperature, really cool things where we can contribute, and where that data will be collected and used to make an advancement with our field. And the other thing is that it's not just our field that's being affected, it's everyone's field. So we need to also remember that though we're in the weather community, weather affects everybody. So I think it's up to us as young professionals to spread the word about how being a weather-ready nation will be valuable to everybody. One of the questions that we have is, with the advancement of all this technology, programming, changing, and everything, and the exponential rate that it's going, what is actually being done as far as communication between professionals in the field and academia? How are we being guaranteed that what we put on our resume and what we learn in classrooms are going to be valuable to when we walk into the workplace?
Could I jump in on the response to that?
Yes, yes.
So one of the things as we move towards a weather-ready nation, I firmly believe that the meteorologists of the future will look very different than my own training as with 3 degrees in meteorology from Florida State. And I think it keys on what Amanda said. I think the Weather Service and the Weather Channel, AccuWeather, and other private partners are going to be looking for meteorologists that can certainly predict the weather and understand the atmospheric fluid. But they're going to also be looking for meteorologists that have technological skills in GIS training, that understand things like perception and communication. That's why I also encourage meteorology students to take courses in writing and speaking, because we can't communicate what we know from a science and technology standpoint. What good is the information? So I think there is a next generation component to our training of students like Amanda that meteorology programs like ours at Georgia have to think about. As we all know, the meteorology community and our curriculum is very heavily physics and math based, and we take pride in knowing that we're understanding the fluid as scientists, but there are other skill sets that we need. And just one other quick thing, I want to get back to something we've heard about communication. I think it's important to understand, one of the things we teach, and we teach our students at Georgia, and I know others do as well, is the old school forecast funnel. And that is looking at the atmosphere from a big picture and then funneling down to what's happening at the local level. I think today we have a lot of meteorologists, amateur and professional alike, that zoom straight into the model. And so understanding forecast and understanding the atmosphere involves looking at the entire picture and then going to the model and see how that plays out based on your understanding of what happens. I say all that to say that the suite of satellites that NOAA and NASA are advancing, coupled with things like the ASOS networks, dual polarization networks, the new modeling systems that are coming online for improved data assimilation schemes, these things will all improve our forecasting ability. But as we see more social meteorology, and I say media being MEDIA, I think it's important to understand that there are a generation of folks that just know how to look at the models, but we've got to make sure we understand the atmosphere before we're interpreting the models, because the models can generate a storm in the Gulf of Mexico 3 weeks out. But those of us that understand the atmosphere know that that may be a fallacy. So I just wanted to make sure I get that point in for this discussion.
Yeah, and I was wondering if I could jump in here too, and to bring it back, this communication issue, and then bring it back to the students. A critical part of impact-based decision support services, which we're bringing meteorologists to, it's not just making the forecast, but it's providing this decision support, depends on communication aspects, and it actually, once you get into the decision process and knowing how your information feeds in, the social science aspect looms large. So one of the things that I'm emphasizing when I visit universities, that it's not just the physical sciences, it's not just the atmosphere, it's the total system that we need to know. And we need to know the interplay between the physical and social sciences if we're going to take forecast into these decision support services, whether it's coming from the Weather Service or whether it's coming from other private sector firms or the media. So this has got to be a key part, and I think the students actually are aware of this, and they're becoming increasingly active. I should also note that this whole connection with decision support is bringing meteorologists into the emergency management community at every level. Meteorologists are now being hired to help them facilitate their decision process and help them interpret this information that's coming towards their key decision points. So So there's really this wide range, this broad range of activities that need to be considered, as we move forward.
And I want to just focus on this point that you just raised about decision making, you and Marshall both. And I wonder if you or others in the panel can give us more examples of how that plays out, in the sense that I think all of us know in our day-to-day how weather affects us, the decisions that we make based on that, vacation, what kind of clothes to wear. But of course, those decisions, that information also impacts decision at different levels for industry, for local governments. So perhaps give us some examples about that kind of decision.
Yeah, so the kinds of decisions that are made today that weren't even made 5 years ago. Let's say 5-10 years ago, if you would have told me that a superintendent of schools would make a decision to close the schools before the first flake of snow even is within their 5 o'clock in the morning light, that they're looking out there into their backyard, I would have told you you're crazy. That they wouldn't have the confidence in our forecast to make that kind of decision that would affect a myriad of people's actions during that day. To me, that's just a great representation now of what happens in terms of being able to extend forecast capabilities and communicate the uncertainties, that people can factor in the odds into their decision process and make those kind of decisions. And I'll also point out that it's not just the school system. Last year, this year, on the February 14th snowstorm that we had in the Mid-Atlantic region, government decided to close down, federal government decided to close down 9 o'clock the night before. The heaviest snow, there was some snow further southwest of us, but it didn't start snowing in Washington, D.C. until after that decision was made. And the heaviest snow occurred right at the, right before the morning rush hour, as predicted. So it was a wise decision. But I can guarantee you that the angst associated with that kind of decision, both by the decision makers and the forecasters providing information, was palpable. So this is something that is new. It's something that represents an advance across that whole spectrum of actually making the forecast, communicating the uncertainties, making decisions that affect millions of lives.
Laura, could I just quickly add to that? It'll be quick. I just challenge everyone out there watching this Google Hangout to just consider it from the time that they wake up in the morning until the time that they go to bed, how weather impacts their day. From their decision, from their commuting time to the cereal that they ate, the grains that were grown, that depended on weather information. I think studies by Jeff Lazo and colleagues that have been published have suggested that 3 to 4% of gross domestic product is impacted by weather information. And I think more and more we're realizing that. I think if you think about every day, every major airport in this nation, they are consuming weather information. I think colleague Mike Smith, I hope Mike's out there watching, he wrote a really nice article in Washington Post, Jason's outlet, talking about we've essentially eradicated airplane crashes due to wind shear because of weather technology. It's been almost 20 or 30 years since we've had a significant, that used to happen all the time in the 60s and 70s. That's an example of how weather technology literally has made society better or improved our life. And of course, there are other factors at play. But the point being, I can't imagine transportation activities at major airports, military decision planning here and abroad taking place without the valued weather information that's being produced by our federal partners and also by the value-added products from our private partners as well, and the research from the academic community. They all work together, the academic, private, and federal sectors.
And if I could jump in, go ahead, Jason.
Okay, I just wanted to confront a misconception which is out there, which you hear all the time, that meteorologists are they're one of the few professions where you can get paid and be wrong half the time, whereas our track record in weather forecasting is that we have very strong accuracy in our forecasts out to about 3 or 4 days. And when you look at other professions, economists, even doctors, the accuracy and the credibility of the information we provide is right up at the top. So I think as a community, we have to continue to educate people about the progress our field has made, and it's a huge reflection of the technology and the advancements of technologies and the investments in the technologies, the satellite systems, the radar systems, which we talked about at the top of this program.
And I just want to add, too, with what everybody is saying, back to the academia part, back to extreme weather. I mean, think about the economics of forecasting, making that judgment call. And what Marshall said, you step outside, start your day, think about all of the impacts weather has had on not just your decision, but the business that you're going to, their decisions. You go into a Target and you find a shovel there. Well, it's not by accident. They probably consulted a meteorologist. Should I stock my shelves this week or next month with the shovels? Think about, even something as simple as beer sales, and you correlate that to temperatures and heat waves. Think about that, that economic impact going forward with extreme weather, how that's going to affect our economy in every part of the country, from farmers, retailers, manufacturers. I think that's a fascinating topic, and certainly one that ties in well with what we're talking about, the academics, the economy, and extreme weather.
So it's a whole of enterprise approach. Mm-hmm. So now let's talk about the future. What does the future forecasting look like to you, Maria, and to others in terms of, is it going to be more precise? Is it going to be more localized forecasts? What do you think the future holds?
First up, I think it's an exciting future as far as just the mechanics of forecasting. Talking about all of the new technology is fascinating and exciting. I do think that just from what we experience at the Weather Channel and people who, for instance, use our apps, it's all about the hyper-local. You want to be able to know exactly what it's going to be like, not just for your day, but for a few hours ahead of your day there. That's going to be a big thing, too. And I think with all the technology, we're going to get better at that. I guess we call it that nowcasting. So I'm excited about the future of forecasting. I'm really excited for the future meteorologists, the master students now and those graduating now, because I know just from the time when I graduated, it's a whole other ball game when it comes to technology, the industry itself, your opportunities and the possibilities for you to use that information. So I think it's an exciting future.
Amanda, do you want to jump in? What are you looking forward to? What are you and your fellow classmates talking about today that has to do with what the future of forecasting looks like?
Just like Maria said, I look forward to the endless possibilities of what's to come. I read somewhere that in 2030 they're going to have weather models that are going to have an unbelievable amount of data, just like I talked about before with the supercomputers and stuff like that. So I think all of you are right. We are completely in a whole different ball game as far as the future goes. It's a little frightening, but at the same time, I think it's exciting. The amount of knowledge that we're going to get from all of it, I definitely think it's going to help the future and definitely save a lot of lives. The other thing that has been great is like real-time mapping and Google crisis mapping, getting people out of areas, getting people prepared. Also with social media, we have apps now that can help people not only prepare beforehand, help them during the crisis, and help them afterwards. I mean, we have so much information out there that people can use in their advantage that it's wonderful, and I'm actually very, very excited for our future.
Yeah, and if I could jump in here, I think the future is now, actually. As I mentioned, it's not just Earth system modeling. It's not just the modeling aspect. It's the workforce that we have in the Weather Service now that's dealing in interdisciplinary roles in ways that they weren't even 5 years ago. So we're working with folks from the National Ocean Service, for example, in the forecast for ecosystems, where our folks are actually interacting now with their scientists as they develop harmful algae bloom forecasts that are now released through a forecast office. And the forecasters, the Weather Service forecasters, I think, understand that it's not just the atmosphere. It's this whole combination of activity and interactions within this Earth system that involves the oceans, the atmosphere, ice, and land. and be able to deal with this from a prediction point of view that meteorology has actually been on the forefront of, and then related to that impact-based decision support into these other areas. So, which again gets us into social science and other scientific attributes that need to be brought to the job. So we're looking for, when I talk with students, when I go to the universities, we're looking for this interdisciplinary approach. When I work with the employees within the Weather Service, we're talking about training that's needed to continually build up this capability within the Weather Service with our existing workforce, and we'll move ahead accordingly.
Yeah, and I would add, I really look forward to a couple of things. Higher resolution model capabilities. We're seeing the model resolutions become better and better as our computing capability gets better. So an era of precision forecasting at very fine scale, like you alluded to, Laura, is very exciting. If your viewers or the people watching don't understand what I mean by resolution, just think about a digital camera on your phone. A 20 megabit pixel picture is better than one that's 5 megabit. So as the more resolution, the more data points we have in the models, the better we can start to resolve things like individual thunderstorms. We can start to represent things like the urban land cover or other factors that may cause problems in our forecast right now because the models just can't resolve them. So I think that's exciting. And finally, I'm excited about the things we can't see. When I was a student at Florida State back in the late 80s, early 90s, I couldn't have envisioned that a satellite could measure the surface winds from space, or that we could look inside a hurricane with microwave technology or precipitation radar like we have on the NASA GPM satellite. So there are some things that I know that are over the horizon that we can't even see, and so that's what makes it fun for us as scientists. You know, we get paid to think about this next generation technology, and that's who couldn't ask for a better job than that.
And a lot of those innovations are also coming from the private sector, as we discussed before. Louis, we got a question from one of our viewers for you. Our viewer asks, what kind of innovations can the private sector bring to the table to help the National Weather Service in its mission?
Well, we actually work with the private sector across the entire spectrum of what we do, but when people, in fact, it came up during this session, the social media and information into the Weather Service through cell phones, how we get our information out through cell phones. We now have our warnings that are done or provided through wireless emergency alert systems. All this, you know, I go to these commission meetings in the American Meteorological Society with all these new businesses cropping up in the existing businesses, and you know, they're developing applications on cell phones in ways that, you know, again, as you just see this rush. Well, we have to make sure that our information can plug into that, and in ways that get the message out, that could be life-saving messages directed right at where the people are, and this is happening, and the private sector is helping to lead that effort. Of course, in the models and observation systems, we work again with the private sector firms and partners, you know, as we move forward. So, you know, that connection is pretty solid now within within a large parts of the government and the National Weather Service.
And going back to this link between societal action, what the general public can do, and all of these tools that are available, Marshall, I wanted to ask you about an initiative by AMS called Living on the Real World, and that's also a book by AMS Bill Hook, on the relationship, our relationship with our environmental challenges. So for most of us, the challenge is defining what we can do, what role we can play in the solutions. Do you have any thoughts to offer about how we can be more involved in that?
Well, the American Meteorological Society and Bill Hook, who's Deputy Executive Director, and a phantom just handed me the book here. Living on the Real World, which is a recent publication of the American Meteorological Society, and the author is Bill Hook, who's right downstairs at our AMS Executive Council meeting. I want to mention that professional societies like the American Meteorological Society or the National Weather Association are organizations rooted in, I know what our Director of Communications, Tom Shampoo, talks about, community and science and partnerships. And so it's important that organizations like the AMS or NWA provide linkages. There are things like the forecast discussions, the technological advancements that we've been talking about, guidelines and best practices for certifying broadcast meteorologists and perhaps in the future digital meteorologists, some type of certification or seal. These things all come about because of the interactions in these professional societies like the AMS. So, you may not necessarily agree with one aspect of what the AMS does or the NWA, but I argue that these organizations are collectives for the greater good for our weather enterprise. When we see things like government sequestration or limits on how our federal scientists can travel to science meetings, or challenges in funding for our private partners out there like Northrop Grumman or the weather companies or AccuWeather, the AMS is an objective platform for advancing the better good of the weather community. So students can be members of the AMS, enthusiasts can be members, we can encourage our professional societies to be members, because to get at your question, Bill talks about living on the real world, and what he argues is that thinking like a meteorologist can actually improve the planet. And with our climate system going through some changes, with extreme weather events affecting more and more populous regions like coastal areas and cities, the way meteorologists think in terms of how we problem solve, synthesize data, and then apply them have lessons for the broader community. And I think that's one of the things that Bill is trying to get at.
And I will add to your response, I'm glad you talked about the value of joining organizations like this. It's also joining the American Astronautical Society and other professional organizations that also have a real benefit to young professionals. I am a testament to that. And I think, Amanda, I wonder if you and your colleagues are also thinking about joining these kinds of organizations. It's a great way to get involved and just continue the conversation with folks in other stages of their careers.
I think Marshall had a great point about linking societies and people. We do a lot here at Millersville University. Next week we're going to have a preparedness day because this month is the preparedness month. We're going to be joining vendors like Lancaster Emergency Management, people from AMS, University Police, something like that. We're going to start trying to get people aware and to be prepared, and we're also going to teach them how to make plans, how to make kits, make it fun, offer kits for people and prizes for everyone who joins and makes a pledge. And I think what NOAA and all of us right now are trying to do is to get a weather-ready nation and get not only companies, communities, universities, everybody to try to be weather-ready. I think the most difficult part is to get people involved who don't technically, to know in your opinion, experience extreme weather in their areas, but some other areas that do experience it, they're more involved into being weather ready. But I think everyone should always be weather ready, because you never know what's going to happen or when it's going to happen. Just like a couple years ago, there was an earthquake in our area. We never would have thought we would have had an earthquake. But it could be next time. You never know. But the point is to be prepared, and that's what we're here to tell everybody we need to be prepared. Being a weather-ready nation is important.
And we also have a question now for Jason and Maria. You talked about authority in terms of authoritative sources in terms of weather information. And this viewer asks, how can the average person distinguish between reliable and not so reliable weather-related social media messages?
Sure. So I can start with that. I think you just have to educate. It's a self-educating process, and you have to sort of look across the spectrum and each and every day tune into your local weathercasts on TV, tune into the National Weather Service, look at social media, look at Facebook and look at Twitter, and who's resonating with you. Who's there providing good information? Who's there answering your questions? What information do you find most useful? It's a very personal issue, but I think it comes back to evaluating the sources which are out there and finding out what works for you. And of course, as meteorologists, we can recommend the National Weather Service because, of course, they're a trusted source. We can recommend the Weather Channel, the AccuWeather. I mean, pretty much all of the major players in the weather enterprise provide really good information. But at the end of the day, because there are so many sources of information and there are so many choices, you have to decide what works best for you and who's providing the information that you rely on and the information you need.
I think what Jason brought up is absolutely perfect. You know, you have a lot of available sources, but you do have to pick one that you're comfortable with and you find authoritative. And I think also a great way to think about it too is, like, if I look at Jason's Twitter list of who he follows, I'm guessing there are going to be some solid meteorologists and weather sources there. You look at who Marshall follows, and I know there's going to be fantastic sources there. So about educating yourself and making an educated choice.
And just to throw in there, just look, if it passes the smell test, they really sound dumb, and you can see that they're hyperbolic. So, I mean, viewers and consumers of information need to use common sense on some of this. If someone's predicting a snowstorm is going to hit 45 Beacon Street 4 weeks from now, that just doesn't pass the smell test.
Could not have phrased it better.
Going old school.
Yes. Louis, we also had a question about one of the new systems coming up, GOES-R, and this viewer asks, how will GOES-R help improve public safety in the future?
Well, yeah, GOES-R represents another revolutionary change in an observing system with 16 channels, being able to cover the disk, depending on what mode it's in. You know, we can get 5-minute data, 15-minute data that, you know, cover a wide range of channels now, including 3 visible channels. So from a situational awareness perspective, we're going to get that much more data and insight into things, not just the hurricanes and severe weather that we're used to seeing on TV, but fire weather aspects, space weather. There's a space weather instrument on it. Lightning, the lightning detection. I point out that usually lightning is the first indication of a severe or of a convective storm forming. You see it on the radar once the rainfall actually starts. So there's extra lead time there. But just the fidelity of the data, the timeliness of it, and is going to make for an incredible advancement in situational awareness. And we're working with the GOES-R project to enhance our 4-dimensional data assimilation system so that we can start ingesting that kind of data with that kind of delta T, and that should also then affect our model performance as well.
And Marshall, a question for you in terms of just help viewers understand what the steps are, some of those sensors that Louis was just talking about, and forecast. What are the steps one to the other, and that us?
Yeah, I don't know if anybody else is getting that, but there was some tremendous feedback. Your question. Did anybody else hear?
It was a little choppy on my end as well.
Okay, I think you said one of the steps is going from those advanced options from GOES-R and other forms to models and decision making. Is that kind of?
Okay, I got a lot now. Let me see. If folks mute yourselves while I ask again. Okay, I think that's better. Marshall, let's just say summary again and observation to the viewer. How those steps connect.
Okay, I still have a question from you, but I'll the question. I thank you. So these data sets and technologies, GPSS, satellite. This information is assimilated in forecast models. So again, I want to emphasize that the neural model is because it utilizes data coming from our technology. The data, as the models to update those models and produce better assessment of what the atmosphere looks like. That's starting the model and the time. So it makes for a better weather prediction forecast. In addition, understanding where you have lightning is going to use it to, that gives you an indication of where you have thunderstorm, convection, and potential hazards to the public. So, you want me to, it sounds like there are technology issues here, so stop the there because I really don't quite know what you asked me.
Well, I think that works, and actually we're only 6 minutes away from closing up. So I wonder, I'm just going to open the floor and to any of you that want to make another point or maybe raise something that we haven't.
I would. Yeah, this is Louis, and hopefully you're not getting an echo from me. Is this okay? Yeah. Okay. So one of the things I want to close with was we've been talking about advancements over the horizon. I want to just point out some things that are going to happen on this side of the horizon. We're going to be updating our computer system. We're going to be extending it from 200 trillion calculations per second to 700, 7 teraflops by January. As we increase this computing capacity, we're already planning on putting in the high-res rapid refresh by the end of this month. We're increasing our GFS resolution to 13 kilometers by November. And as we improve the computing capacity next year, we'll be increasing the resolution of our ensemble forecast systems, which I consider to be top of the line, from mesoscale all the way up through into the climate arena. And we'll be approaching our 4-dimensional data assimilation by the end of the next calendar year. So all these things are happening now on the physical side of this ledger that I believe will really be enhancing our forecast capability, not only for the Weather Service, but for the entire enterprise.
I guess I'll jump in if we're doing concluding statements. I just want to thank Northrop Grumman, the American Meteorological Society, the American Astronomical Society, and all of my colleagues on the panel and all of the viewers out there. I think not only are we a weather-ready nation or becoming one, I think we're increasingly a weather-interested nation. Weather, unlike many sciences, engages the public. It's something they feel like they understand, that they experience. So it really is an exciting time. Shameless plug, the Weather Channel now has a show called Weather Geeks each Sunday at noon Eastern. And look, I really am getting that out there because we talk about these very issues. We've had Jason on, we've had Louis on, and it's an opportunity for us to geek out about weather, and we cover the spectrum. So happy to have you all join us, and thank you all again for this opportunity. It's really important for the nation.
And unfortunately, our hour is up. Join me in thanking our wonderful panelists for sharing their insights, and thank you for watching and for taking part. This brings our AAS and AMS Hangout to a close, but remember, the conversation keeps going. Remain engaged via social media. Share the link of today's Hangout with your friends and family that weren't able to watch. We are calling out on everybody to celebrate and enjoy the benefits of the next surge of weather science and technology, and to join us in building a weather-ready nation. Maybe we're there, but maybe it's about getting better and meeting the challenges coming up. So thank you again.
Your last tweet, that was fun.
Thanks all.
No, I saw the one. Thank you, guys.
Good to see you, Marshall, Louis, Maria.
Yeah, exactly.
Amanda. Thanks.
Nice to see you too.
Always a pleasure.
Good seeing you guys.
To virtually meet you, Amanda.